Hey Math 1, I've got a new video for you. It is a slight extension of what we talked about in 5.3, the idea that, hey, you need to get y by itself to create y equals mx plus b slope-intercept form type situations. I'm just extending that to this lesson and talking about a few of the special cases that show up. It has the potential to be mildly difficult, but yeah, math can be inconvenient, so we'll deal with it. All right, so what happens, this is beyond the basics, what happens when decimals and fractions worm their way into the mix? We don't usually like dealing with those. So I presented to you guys two equations that have decimals implanted in them to begin with. Well, we have a strategy that we've been using for a long time to get rid of these decimals, right? You multiply both sides of the equation by 10, at least 10 in this case because it's just one spot after the decimal that we're concerned with, and that creates not 1.8x, but 18x equals not 5, but 5 times 10. 50, and not minus 3y, but minus 30y. So once you do that, you've got an equation without decimals. Okay, we can work with that. Now, I gotta make it look like this. So the first thing I'm gonna do is rewrite it to where the y is on the left-hand side. So I'm gonna add 30y. And there's no y's over here to combine with. I'm just going to say plus 30y moves it to the left. Now the y's on the left. Yeah? And I'm going to subtract 18x as well. So now my 18x is no longer on the left, but it's on the right, just like the x is on the right for our slope-intercept form. So now that this is completely gone, I'm left with 30y. This is completely gone. I'm left with negative 18x plus 50. So big numbers we're talking about right here, but those big numbers are going to be divided out by another big number. Divide by 30, divide by 30. So now we got to deal with a big fraction here. Remember, the m needs to be reduced as a fraction because it represents the rise over run. So negative 18 over 30, you could go off to the side here and ask yourself, how do I simplify negative 18 over 30? Well, you can cut it in half. Half of 18 is 9. Half of 30 is 15. They also divide 3, though. So divide negative 9 by 3, you get negative 3. Divide 15 by 3, you get 5. So this is the same as y equals negative 3/5 x. All right? Plus, if it's 50 over 30, you can instantly divide the top and bottom by 10, canceling out those zeros. 5 over 3 is the same as 1 2/3. Okay, so this is the equation. There's the little box underneath here that I still want you guys to fill in. If I move the screen, then this grid will get... Here, I'm just going to do it over here. So in the box down here, you'd write m is equal to, for slope, negative 3/5. That's what goes down here. And then our b value is going to be 1 2/3. So we're starting on the y-axis, all right, the vertical axis at 1 2/3 units up. So go up 1, then go 2/3 of a unit. So closer to 2 than it is to 1. Then from that point, I'm going to go down 3, so down 1, 2, 3, right 1, 2, 3, 4, 5. Okay, so still in between the two blocks, okay? Then also you could go up 1, 2, 3, and left 1, 2, 3, 4, 5. Remember, m could be negative 3 over 5 or positive 3 over negative 5. You got two options there. Okay? You graph it. And you're done. Let's check out number 2. Actually, why don't you pause the video and try 2 on your own? All right, let's see what you got. You should have probably multiplied both sides by 10. That's our best strategy. You get 10x minus 12y, remember you just moved that decimal place over, equals 80. Now I need to make it look like this, so I need to move the x's to the right. It's positive 10x, so I'm subtracting it. That gets rid of it. So you got negative 10x plus 80. Divide everybody by negative 12 to get that clean y. Now a negative divided by a negative yields a positive value. They're both even, so I can cut them in half. Half of 10 is going to be 5. Half of 12 is 6. And again, I'm disregarding the negatives because a negative divided by a negative is a positive. The x is still there. And then for 80 over 12, I probably want to turn that into a mixed number if at all possible, since it is the b value. It's the starting point. But maybe reducing the fraction before that would be wise. They're both even, so I can cut them in half. 80 divided by 2 is 40. 12 divided by 2 is 6. Still even. Half of that is 20. Half of that is 3. All right, so this is a little easier to actually find the mixed number. 3 goes into 20. 3, 6, 9, 12, 15, 18. 6 times plus 2 left over. So it's a negative number. Negative 6 2/3 would be that value there. So I've got my slope. M equals 5 over 6, which is the same as negative 5 over negative 6. You can go in both directions. And then our b value is going to be negative 6 2/3. So I'm going to start almost at the bottom of this grid. Down 1, 2, 3, 4, 5, 6. Then 2/3 of the way down, closer to 7, negative 7 than it is to negative 6. From there, I'm going to go up 1, 2, 3, 4, 5. Right 1, 2, 3, 4, 5, 6. Now, normally I'd ask you guys to plot a lot of points. But here's actually the trick. The trick is to get accurate points that are as far away from each other as possible. The more accurate your points are, farther away, means everything in between, if your line is accurate, is going to be right too. So the fact that they're this far apart is okay that I only plotted 2 points. Also recognize, though, that you did have the strategy of cutting the 5 in half, 2.5, and cutting the 6 in half, 3, to go up 2.5 and write 3. But since we started at a 2/3 value, probably don't want to do that. All right. I jabbered on too long probably on that, but I don't know. Hopefully you got something out of it. There's our first 2. Let's check out number 3. Oh boy. We got fractions too. Now, we dealt with these fractions a lot back in the solving equations chapter and a little bit with the solving inequalities as well. The easiest way to get rid of fractions in an equation, is to find the common denominator. All right, so let's make everybody, let's see, what do we got here? We got 3y over 5. Remember, the variable goes into the top of the fraction if it's beside the fraction. Plus 3x over 10 equals, I'm going to make that 4 a fraction, 4 over 1. So what's the least common multiple between 5, 10, and 1? AKA the smallest number that would divide them all evenly. The answer to that is 10. So I would take 5 times 2 and 3y times 2 to get a denominator of 10. This one's already 10, so I don't have to do anything with it. This one needs to be 10, so I got to take 1 times 10 to make that happen. So I've got 6y over 10 plus 3x over 10 equals 40 over 10. Now, if you recall, I gave you guys a rule back in the solving equations chapter. If I multiply both sides by 10, then through fraction cross cancellation, all these 10s disappear. So the quick and fast rule is to say, if you found common denominators amongst all terms on the left and all terms on the right, then you can ditch the denominator. Just solve the equation you see in red. So we've ditched the denominator, and we've got something fairly easy to work with now. 6y plus 3x equals 40. So it took some work to get there, but we've created an equation that's much easier to work with. So over here, I'm going to work with it. Can you guys see that whole thing? Barely. So we want y equals mx plus b. Get that negative 3x to the opposite side. I can't combine these terms. I just write it as negative 3x plus 40. Divide both sides by 6. All parts by 6. Hopefully this is pretty, what's the word? Immediate in your brain. Like, hey, negative 3 over 6, I automatically look at that as negative 1/2 x. Which means negative 1/2 is your slope. Or 1 over negative 2. Your b value is going to be, wow, a lot of mixed numbers on this assignment. Hey, that's the one we just had. 20 over 3. 6 2/3. Although this time it's positive 6 2/3. There's our equation. We already got the slope written. The starting point's going to be 6 2/3. That means it's up 6 2/3 on the y-axis. 1, 2, 3, 4, 5, 6. Closer to 7 than it is to 6. Yeah, I can't really do much to the left of this because I've run out of room. So I'm going to have to go down 1, right 2 a bunch of times to plot some points that are accurate. So down 1, right 2. Down 1, right 2. Down 1, right 2. And it's pretty safe to just say those 4 points will do. All right, so if you have decimals, multiply by 10. That gets rid of the decimals. If you get fractions, find those common denominators and then ditch them. What else could we see here? Oh, yeah. Okay. What happens when we get ridiculous slopes? Like something like 14 over 5 where our grid space doesn't really allow for a whole lot of increase in value. All right? Or something like negative 12 over 7. Well, first of all, recognize that this is the same as negative 12 sevenths x plus 5. The negative only is given to either the top or the bottom. So m is equal to negative 12 over 7 or 12 over negative 7. So it's not negative 12 over negative 7. It's not that. Now this one starts at 1, 2, 3, 4, 5. Because that's our starting point, positive 5. Can it go down? Can it go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12? Yes, it actually barely fits. 1, 2, 3, 4, 5, 6, 7. So, okay. This wasn't the example that I wanted to start out with, but yeah, you can get 2 points on this grid. What I was talking about was what happens when you can't even get one other point than your starting point on the grid space. And here's a strategy for that. If you get something like 12 over 7, and I've already talked about this, I just thought it'd be nice on this video to really hone in on it. You can cut the top and bottom in half even if they're not both even. So if I cut the top in half, I get negative 6. If I cut the bottom in half, 2 goes into 7, 2, 4, 6 times, and then there's a half left over. It's 3.5, 3.5. You can use that rate of change that more adequately fits the dimensions of this grid space. So from here, I could have gone down 1, 2, 3, 4, 5, 6, write 1, 2, 3, and then go half a unit. And that point should accurately fit on that line right there. So same thing over here. This one has a starting point of -4, a slope of 14/5. This one, I'm pretty sure, will not fit the dimensions of this grid space at all. If I go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, we're way in the white right here. So we should be thinking of 14/5 as, if you cut the top in half and the bottom in half, you get 7 over 2.5. So I've plotted my first point. Now, instead of going up 14/5, I can go up 1, 2, 3, 4, 5, 6, 7, write 1, 2.5. This is just a good skill to have in your back pocket because it shows that you can think on your feet. You're not just like, well, I ran out of grid space, so I can't do anything. Of course you can do something. You've got a really powerful computer up here. All right, last ones. This is going to be a little bit lengthier video than what you guys are used to, so please forgive me. Extra special cases. All right, these are the ones where you really have to commit to memory some things that are just kind of wonky. These extra special cases do not fit the y equals mx plus b mold, okay? They're outsiders. They don't fit the, hey, check the get y by itself and check the m in front of the x and the b there. It's literally y equals -2 and x equals 3. So the first thing to talk about here is really just use the equation to think through what this line would actually look like. I'm actually going to start with number 7. Here's my y-axis. This is y equals 0. This is y equals 1. This is y equals 2. Sorry, I don't know if this brightness is showing up really poorly on my end. Here, let me try that again. Here's the y-axis. This would be y equals 1, 2, 3, 4, 5, 6. Okay, so y equals -2 would be down here. That's the point 0, -2, where the y-coordinate is -2. Well, what about 1, -2? The y-coordinate also equals -2 there. Well, 2, -2. The y-coordinate's -2 there. -6, -2. -5, -2. 7, -2. All of those are points on the graph in which y equals -2. All of those are points on the graph in which y equals -2. Remember points, x comma y. The y-coordinate is always -2. It's a horizontal line when you see y equals just a constant number. So if you see y equals a constant, it's a horizontal line. And what would the slope of a horizontal line be? Well, think about your rise over run. Just pick 2 random points on this grid space right here. Let's pick this one and this one. What's your rise? You go up 0. What's your run? 1. Can I take 0 divided by 1? Of course you can. $0 divided by 1 person means he has $0 to give to everybody in the group. All right. The slope is 0 for any horizontal line. You might want to put that in here. For any horizontal line. I'll just put for any horizontal. Y-intercept, that's easy enough. It's the actual spot where y equals, because that's the place where it's going to cross the y-axis. So b equals -2. Awesome, awesome. All right, so those are how horizontal lines work. They don't really fit this mold at all. Neither do vertical lines. So think about this. Here's our x-axis. When it says something like x equals 3, it's talking about 1, 2, 3. This is the point 3, 0. 3 is my x, comma 0. How about 3, 2? That's another point in which the x equals 3. That's 3, 2. How about 3, comma -6? These are all points in which x equals 3. So when you see x equals a constant, you have a vertical line. You might want to write that down in your notes somewhere. X equals a constant means it's a vertical line. These two are connected, just like these two are connected. Now let's test this whole idea of the rise over run again. Let's pick two random points. How about this one and that one? So let's start here. What's my rise? Up 2. What's my run? It doesn't run. It's 0. Oh my goodness. If it doesn't run, it's a very special case. If it doesn't run, it's a very special case. It's like a number that has broken down completely. You literally cannot take 2 divided by 0. And there's a whole explanation. I could throw YouTube videos at you with that as well, but I'm not going to go into. You can't divide by 0. This is a divide by 0 error. It's a number that's complete gibberish. It doesn't have any kind of meaning in the actual number world. So what we do is we say that this slope, for any vertical line, we just say it's not a defined value. So that's kind of like the mathematical way of saying it's a divide by 0 error. So undefined, and that goes for any vertical line. And you know what? Doesn't have a y-intercept. It never crosses the y-axis because it's parallel to the y-axis. So I'm just going to say there is no y-intercept. And I think we'll leave it at that. This video is pushing over 23 minutes already, so hopefully you guys endured it and made it to the end. All right. Thank you for watching, and make sure you get the homework. Adios.